I'm going to try. Okay. So we switch the secant squared, very good, Seneca, over to a 1 plus tangent squared. And now what's u going to be here? U has to be tangent, which means du has to be secant squared x dx, which means that integral is going to become, look, we can do this all in one step, u to the 4th plus u to the 6th du. Are we okay with that? I just distributed the tangent to the 4th into here. And then secant squared is the du. Now, if we had an odd number of secants, that would not work. Okay? Good talk. So when we integrate that, we're just going to get 1/5 tan to the 5th of x plus 1/7 tan raised to the 7th of x plus c. Ta-da! Feeling good? Oh, who read? I forgot. Can you just grade? I know you first. You have to grade. Cortana. Cortana. Yeah, he's right wrong. Yeah. Oh, yeah. So I show you. Why are we singing this? Okay. Yo, let's go back. Check this out. If we have an odd number of tangents, switch those over to secants except for one, because then we could have a secant tangent as the du. So we either need an even number of secants or an odd number of tangents. Okay? Don't have either, then we're going to talk about those special cases. That will happen. But in this case, I'm going to switch the tangents over and leave just one. Okay? Watch this craziness. So this is going to become, oh, I shouldn't have stopped writing. Don't worry. I'm going to get this to work. I'm determined. Huh? I'm going to get... It was just working. I'm just going to break it. I'm going to smash this thing. There we go. Okay. Blah. So again, we're going to switch over at one tangent. Check out how this works. Look, I'm going to leave a secant squared, which means I'm taking one of those secants away. I'm moving it to the end, okay? So it's still there. I'm just moving it. I'm going to switch over tangent squared to secant squared of x minus 1. We okay with that? How many secants do I have left to put at the end? 1. How many tangents do I have left to put at the end? 1. So at the end, we have the sextanks. Blah. Okay? I don't know. I like it. Okay. Anyway, what's u going to be? Secant. Okay, not secant squared, just secant. It's okay that it's raised to a power, which means then du gets to be secant x tangent x. Which means that integral becomes the integral of u to the 4th minus u squared du. Are we okay with this, David Caesar? You sure? 100%. What extra secant? Here? Remember it was secant cubed? I took one away, now it's secant squared. I'm just moving it to the end because, again, I'm thinking I need my du to be secant tangent, so I'm just taking one out there. Okay? So this is going to become 1/5 u to the 5th, where you're integrating it, which is 1/5. You could probably just skip that step there and just go right to this, right? Ta-da! It's over by the flag. Are we good? So if tangent's even, switch them over, leave two secants. If secant's odd, switch them over. No, I'm sorry, if tangent's odd, I apologize. Switch them over, leave one, and get the secant tangent, okay? Let's see. He's just a dude.
What subject was that? Bernoulli numbers.
Bernoulli, it pops up in stats, but he did a lot of calculus stuff too. He was all over the place. Okay? If there are no secants, hello. If there are no secants, and we have even tangents, see what this says here? We're going to do this rule repeatedly until we get everything down to secants, okay? Good talk. So, here's how we're going to handle this. Ready for this craziness? We're going to rewrite tangent squared as 1 minus, not 1 minus, I'm sorry. Convert tangent squared to secant squared, distribute, repeat if necessary. Okay, great. It's going to be secant squared minus 1, and we have 2 of those. You okay with that? Well, same thing, same thing. Well, actually, no. Let's leave it like that. Here we go. This makes more sense. The reason why you don't want to convert them all over at once is because when I distribute that tangent, I'm going to get 2 different integrals. You guys see this? Like this tangent is going to go into here. Which one of them can I handle right away? The tan secant squared, right? Because that's a UDU, easily. Okay, so you switch over one at a time, distribute, and then you're going to have to do it again. So if that was tangent to the 6th, we could do it, but we have to keep like doing this. But one at a time, distribute, okay? So when we do that, we are going to get tan squared x times secant squared x. And it should be minus another tan squared x. True? But I'm just going to switch. So we can't handle tangent squared. We can handle secant squared. So we're going to switch that over to, I'm going to leave this like this. Tan squared. We can actually integrate this first part. Cool. I'm also going to split it up into separate integrals so I don't have to do like a UDU on the whole thing. Okay? And tangent squared I'm going to rewrite as secant squared minus 1 dx. And we can handle both of those integrals. Okay with this? Yeah. Guys, this works. I don't know why I separated this to if k is even. If k was odd, we do the same thing. All right? If k is odd, you do the same thing because then, like if it was tangent cubed instead of tangent to the 4th, then we would just have one tangent out here to the 1st power, which we could still handle that. All right? Integral is negative ln cosine. Okay? But anyway, when you do this, you can do a UDU on the first one. U is tan. Du is secant squared. So that's going to become the integral of u squared du minus, if you integrate secant squared, you get tan. And if you integrate 1, you get x, and it's going to be really plus x. So I just integrated that second thing, and I distributed the negative into it, okay? And then integral of u squared is 1/3 u cubed. So that's 1/3 tan cubed x minus tangent of x plus c. And if you're really thinking from the beginning, you should have seen that was going to be the answer anyway, really, right? I mean, you could probably just, that's fairly intuitive. That it just jumps right to that.
Okay.
Math jokes. Shut up, Haley. All right, let's keep going. Other questions? Are we feeling good? So all you got to do, guys, you got to organize this in your head. But again, it really comes down to we can integrate secant squared and we can integrate secant tangent. Okay? So if the integral has no tangents and m is odd, you got to use parts. Yo. The worst case of that is going to be this. We're not going to see. So if it has no tangents, right, Judy Kim? Is this on your phone? You're looking at that? Good work. Okay? We did this the other day. We did parts, remember? I'm not going to do it again right now. It should be in your notes somewhere. We did parts. Okay? This is the word. We won't see secant to the 5th. That'll be nuts. We're not going to do secant to the 5th or anything like that. Yeah, it'll be nuts. Okay? What's wrong with nuts? Nuts the food. Okay. And if all else fails, you can always switch to sine and cosine. I don't even have an example of that. Okay. This is good. So, let's practice some. I gave you some homework. We can look at those two. Hold on. Let's see how many of these I have. We have 1, 2, 3, 4, 5. Is that it? 5. Can we handle 5 integrals?
Yes, Cortana.
Excellent. Have fun. Should we do this together? You guys want some help?
No, let's do it first.
Yeah, let's try it first.
Well, David, you say it because you can get it, man. These other clowns, they're not as smart as you. Yeah. You see how well my pen's working right now? It's awesome. Maybe I should pause this so we're not wasting time. How good this pen is working. I'm so happy. All right. Are we recording again? Is it happening?
Yes.
Yes. Listen, yeah, guys. Because tangent's odd, we're going to switch them over except for one and have one tangent left over. And if you need to get a secant tangent and you don't have a secant, just multiply secant on top and bottom. It's going to work out, I promise. Okay? It's not too much. We're going to rewrite this as secant squared x, minus 1. We okay with that? Times that tangent. Now it's over secant to the 1/2, true? But watch what I do here. I want a secant with that tangent, so I'm going to multiply that by secant. I'm just going to put it there. I'm allowed to do that as long as I put one on the bottom, too. So what's that going to be? Secant to what power on the bottom? 3/2. Oh, no, Pen, I was just talking about how great you were doing. Now look at you. I don't know what to do. It just like stops working at random times. So 3. This is like my 4th one. It's just Acer is a turd with pens. Anyway. That's funny. You like that? Okay, good. U is going to be secant, du secant tangent then. And this just boils down to something we can handle really easily. That's u squared minus 1 over u to the 3/2 du. Cool? You like that? It's like magic. You believe in magic. Okay. Oh, that's even better. Damn. Let's just stop learning math and do School of Rock, but just chorus style. A cappella. Okay. You get this, and when you integrate that, you're going to get u to the 3/2. You get that? This is great. Was that a Weezer song? Who sings that song?
No, God, no. You'll be in Bruno Mars.
Really? Didn't Weezer have a magic song some time ago? They had a song about magic or something. Like the magic stick or something. Remember that? Yeah. All right, anyway. There we go. Can we handle this? Huh? And it makes sense, right? Again, you just got to think about the du you got to get. Let's keep going. Here's another one. Boom. What are we going to do here? Yo, this is going to have like 1,000 views. I'm telling you.
I need to have more memes for it to be 1,000 views.
Nice. You should charge them for it. You can make that money.
Mr. Smith,
Huh?
you don't want geometry?
What geometry?
Stoichiometry?
Stoichiometry? No. Yeah, what are we going to do here? What's the plan? Come on. I imagine you're all saying the correct thing in a jumbled chorus.
Sure.
We're going to, leave one tangent. We're going to take one secant. This is just like the other one we did. You see this? Boom. I took one secant, put it at the end. I switched the tangent over to secant squared minus 1.
Oh, you switched the tangent.
True? No, come on. Catch up.
You mean 3x?
Oh, yeah, 3x. I'm sorry.
Yeah. Because secant.
Oh, yeah, you're right. No, we got two ways to do this. We can switch them all to secants or tangents. Either one will work. So look, this is going to become, so u in this case is going to be secant of 3x. So du is going to be 3 secant 3x tangent 3x, which means we need to put a 1/3 out front. A 3 inside and a 1/3 out front. So we need a 3 here, a 1/3 out front, and that's going to become 1/3 the integral of u to the 5th minus u cubed du. If we did it the other way, and you're absolutely correct, we could do that. We could switch the tangent squareds over. Sorry, the secant, yeah, so if we did that, the integral would become, look, we would take secant squared and rewrite that as tangent squared 3x plus 1 times tangent cubed 3x, you okay with that? And then leave a secant squared 3x at the end. And then u would be tangent, and du, tangent 3x, and du would be 3 secant squared 3x. That'll work out too. U would be tan, because then du would be this back here, secant squared. Cool? Yeah, you would still need 1/3 out there. But so when we integrate this, the first way I did it, you get 1/3, so this is going to become 1/6. Now in this case, I did it u with secant. So it's going to be secant to the 6th of 3x minus 1/4 secant to the 4th 3x.
That's the first.
That's if u was secant. Okay? So sometimes you got options, you can do either one. I don't know, whichever one you like better. They're both about the same amount of work. What's wrong? Because u is going to be secant of 3x. So du is going to be secant 3x tangent 3x times 3. Right? Okay, so these aren't that bad. Can we keep going? That was a, how did I get all the way up here? Oh, it's u to the 5th. So when you integrate, you get u to the 6th divided by 6. There you are, San Fran. 10. We good?
Yeah.
Okay. Oh no, tangent to the 4th. What are we going to do?
Is there already those?
We actually already did this exact integral.
Did we?
Yes. Really?
Lies.
It's right here.
Like 10 minutes ago. But let's just go over it again. You switch over 2 tangents at a time.
Oh yeah.
You know what, guys? Let's go ahead and make this cubed, just so you can see that it's a little bit different if you make it cubed. Okay? Yeah, because then we just have 1 tangent left out here. Does that make sense? But we're still integrating from 0 to pi over 4. Okay with that? Now, if we just have 1 tangent left over, we're going to do the same thing. Switch 2 over, distribute. So multiply. But now we can handle both of these integrals that we're going to get. The first one's going to be 0 to pi over 4 of tan x secant squared dx, right? And then minus the integral of just tangent x. Now, when we did this before, we had that tangent squared, which we had to switch over to secant squareds. But if you just have a tangent, you know the integral for tangent, so you can just do that. Cool? So if you just get down to tangent, you're going to integrate that. If you get down to tangent to a higher power, you got to keep switching them over to secants. Okay? This first one's going to be a u du. U is tangent, du is secant squared. Okay with that? So that's going to become 1/2 tan squared x, and that's from 0 to pi over 4. This is also from 0 to pi over 4. Minus integral tangent is negative ln of cosine, so that becomes plus ln absolute value cosine x, and that's also from 0 to pi over 4. Can we handle that? Let's do some math here. What's tangent of pi over 4 when I plug that in? 1 times 1/2 is 1/2 minus, what's tangent of 0? True, it's 0. Good. Plus, what's cosine of pi over 4? Root 2 over 2. So that would be ln Root 2 over 2 minus, what's cosine of 0?
1.
1. What's ln of 1?
0.
You guys are good at this. 0. Okay? So our answer is a half. And look what they might do to you just to be jerks. Are you ready for this craziness? Check this out. They're going to rewrite this. Do you guys know that root 2 over 2 is the same thing as 1 over root 2? Do you also know that that's the same thing as ln of 2 to the negative 1/2? And you also know that's the same thing as 1/2 minus 1/2 ln 2. If this is a multiple choice thing, you might see that answer, not the answer we got. Just making sure you're, okay, so like, you remember those log rules? But actually, the only log rule I used was that, yeah, if you have an exponent, you can bring it down to the front. But it has to be on the whole thing inside the argument. Okay? Scroll up, yeah. So the answer we got here is fine. If it's like an open-ended thing, which your quiz will be, that's a fine answer. But a multiple choice, sometimes logs, man, they make the answers look much different than what you get. Because they hate you. What time? We got so much time left, girl. Okay? Let us continue this. Excellent. I think we have one more. That's it. Oh, we have two more. This is so nice. Boom. It's day 6. Come on now. Integrals. That's how I organize my stuff. Well, I count so I know what to do next. I can't just put the date on there. It changes every year.
Yeah, it's actually just in a real U. So U would be whatever U would get.
How do we do this? This is cosecant and cotangent, but they're the same thing.
Okay.
So let's think here. U is going to either be cosecant or cotangent. It's going to be one or the other. You with me?
Okay.
If U is cosecant, then du is cosecant cotangent, right? Negative or whatever, right? Which means we would need one cosecant, which we could take one away, true. But then we need one cotan, which means we need to switch over 3 cotangents, and we can't do that. We have to switch over cotangents in pairs. Does that make sense? Cool. Now we could try the trick where you multiply the top of the fraction and the bottom, but there's no bottom, so it's not going to work out super nice. Okay? So, that's not a good plan. If we let u be cotan, then du is cosecant squared, which means we have 4. We need to transfer 2 of them to cotangents, which that works out nice. That make sense? So u's going to be cotan. We got to switch over the cosecants, 2 of them. Cool? That reasoning process is, yeah, sounding good? Okay? So I'm going to rewrite cosecant as what? 1 plus cotan squared?
Yeah.
Are you asking us why we read that?
You're just in Calc 2. I'm just a teacher. I'm not like super. You guys are brilliant. And we're leaving 1 cosecant squared. True? True. And then u is cotan, du is negative cosecant. So we got to put a negative in there. Which means there's a negative up front. And we just get negative the integral
Negative cosecant squared, is that
of u to the 4th plus u to the 6th du. Are there any questions on what just happened? It was magic. It was good. You okay with the first thing? Where that u be cotan, du is negative cosecant squared? Oh, well, this is du right here. And u is cotan, so I just distributed this. U to the 4th, u to the 6th. Cool? Because the derivative of cotan is negative cosecant squared. So you got to put that negative in there. Cool? So we're going to get negative 1/5 cotan to the 5th x. Okay with that? Minus 1/7 cotan to the 7x plus c. All good? Excellent. And we have one more to do. And then you can take a look. I'll put your homework up here or something, okay? All right. Plow. What can we do? Okay, great. What are our options? U could be what? Secant or tan, okay? So if U is secant, what's du got to be? Secant tangent. Now let's think about this. We have a secant up top, true? Could I multiply by tangent? I could, but that makes the bottom tan cubed. And if I want everything to be in secants, I got to switch them over to secants, but I got 3 of them, so you can't do that. Make sense? So let's try u could be tan, but then du would be secant squared. We don't have that either. Turds. Skip. So neither one of those seems like a great plan. So what was our all else fails? Sines, cosines. I'd probably go sines, cosines with this one. Okay? So this, check it out. Tangent squared is going to put a sine squared down here. And on top, it's going to put a cosine cube. Nope, just a cosine. Because the secant's going to cancel one of them out. Let me write this. Okay. Secant is 1 over cosine. True. And tangent squared, I'm going to multiply by it. 1 over tangent puts a sine on the bottom squared and a cosine squared on top. That's 1 over tangent right there. Okay with that? So a cosine cancels. This looks much easier. What's you? Really? What's you? Sine, because do you use cosine on top? Yeah. Easy enough. So this is just the integral of u to the negative 2 du. Because u is sine, du is cosine. You just get 1 over u squared. And that becomes u to the negative 1 times a negative plus c. And that becomes negative 1 over u, which was sine of x, plus c. See how that worked out nice? Aren't these your friend now?
No.
They're like old chums.
Would they rewrite that as negative?
Oh, you can make that negative cosecant. So yeah, if it's, again, multiple choice, they might do negative cosecant x. They might not. I don't know. Okay? Yup. Because u is sine squared, right? No, u is sine. I'm sorry. U is sine. And then du is cosine. So the top is du, right? The bottom is u squared, so u to negative 2. It is, but tangent's in the denominator. So it's the reciprocal of tangent. Okay? Okay. So listen, your quiz is going to be like 10 integrals maybe. Some are going to be easy, some are going to be a little hard. So they're all from 7.1, 7.2, and 7.3. Okay? 7.2 was parts. Remember, let's go over parts. We had the table method. Yeah. We had the e to the x times sine x thing where you got to do it twice and move it over. We had secant cubed. Remember those? Yeah. We had ln of x in there. So if you see that, that has to be u. And we also integrated like arc sine. So I'm probably going to give you an integral of like arc sine or arc tan. You guys remember how to handle that?
Yeah.
If you see it, it's just parts. U is arc tan, du is dx. Or dv is dx. Okay? Okay. Trig, you're going to see sines and cosines, secants and tangents. And then I might also give you like ones where you got to split up fractions and stuff. Complete the square. Remember those ones? Yeah. Good talk. If you have, so completing the square is going to be a good plan. So let's say you had that. That's not a UDU. Okay? But if you complete the square on the bottom, you know what, let's make this. So hang on. If we add, then we're going to subtract. So let's make this like plus like 8 or something just to make this work out. Okay? So when you have a quadratic term in there, and there's x squared and an x, and it's not something you can just handle easily, completing the square usually works out nice. To complete the square on this, remember the coefficient of x squared has to be 1, which it is in this case. Yeah? So to complete the square on this, you would do x squared plus 4x. The number we need to complete the square is 4. The plus 8 is out there, and since I added 4, I would have to subtract 4. Everyone okay with that? And that just becomes, check this craziness out, 1 over x plus 2 squared plus 4. What is that? It's arctan. U is x plus 2, and you get u squared plus 4. Yeah, because they like, all the arctan functions, or all the arc functions have like the squared thing in the bottom. So yeah, that ends up doing that sometimes. Yeah.
We're gonna go over everything tomorrow.
I'll give you like a practice one, yeah. Okay, let's turn this off.